Good morning, students. In previous class, we saw about what is keyboard and display controller, and uh, and what are the salient features of 8259, and the detailed pin description of 8279. And in this class, we can see about the architecture of 8279. So in 8079, there is an I/O control and data buffer. So this unit controls the flow of data to the microprocessor, and it enables only when D is low. So the data buffer interfaces the external bus of the systems with internal bus of the microprocessor. The pin A0 read and write are used for commands and status or data read and write operation. Next block is your control and timing register and timing control. This unit contains a register to store keyboard, display mode, and other operations are programmed by the CPU. And also the timing and control unit handles the timings of the operation of the circuit. Next is your scan counter. So whereas the scan counter, it has two modes. One is your encoded mode and second one is your decoded mode. So in your encoded mode, the counter provides the binary count that is to be externally decoded to provide the scan lines of the keyboard and the display. Next is your decode scan mode. So in your decode scan mode, the counter internally decodes the least significant 2-bit and provide decode 1 out of 4 scan, that is SL0 to SL3. Next is your return buffer and return buffer and debounce, keyboard debounce and control. So that blocks indicates the unit first scans the key closer to the row-wise, and if it is found the keyboard is debounce unit, and the debounce the key entry. In case the same key is detected, then the code of the key is directly transferred to the sensor RAM along with shift and control key status. So next block is your FIFO and sensor RAM and status logic. So this unit acts as an 8-byte first in first out RAM. So where the key code of every pressed key is entered into the ROM as per their sequence, and the status logic generates an interrupt request after each FIFO read and operations till the FIFO gets empty. Okay, and in next mode is your scan sensor matrix mode. So this unit acts as your sensor RAM, where each row is loaded with status of corresponding row of a sensor into matrix. So when the sensor changes its state, the line IRQ line changes to high and interrupts the CPU. So next block is your display address register and display RAM. So this unit consists of a display address register which hold the address of the word currently, that is read and written by the CPU to the display RAM. And this is a detailed view of this architecture and design. So it also has a 2-key lockout mode. If 2 keys are pressed simultaneously, only the first key is recognized, and next one is N key rollover mode. Here the keys are recognized and their codes are stored in FIFO. And next in your detailed display section has been already discussed, and next is your operating modes of 8259. There are two operating modes of 8259 that is, one is your input and output mode. So in your input mode, this mode deals with the input given by the keyboard, and this mode is classified into 3 modes. So the input mode is classified into 3 modes. One is your scanned keyboard mode, second one is a scanned sensor matrix, third one is your stopped input. So under your scanned keyboard mode, the keyboard matrix can be interfaced using a encoded or decoded scans, that is 8x8 keyboard or 4x8 keyboard. So the code of the key is pressed with shift and control status. It is stored in your RAM. Next is your scanned sensor matrix. So in this mode, the sensor array can be interfaced with processor using either encode and decode scan. Similarly, here also it is an 8x8 sensor and 4x8 sensor. Stored input mode, when the control line is set to 0, the data on the return lines is stored in your FIFO byte by byte. Next is your output mode. So here this mode deals with the display related operation, and this mode is classified into two modes. One is your display scan, and second one is your display entry. So whereas in your display scan, it allows 8/16 characters multiplexed display to be organized as a dual 4-bit single 8-bit display units, whereas in your display entry, this mode allows the data to be entered for the display either from the right side or left side. And these are the command words of 8279. In the keyboard display mode set, the format of the command word to select different modes of operation of 8279. So here from D0 to D7, where the display modes and its tabulations. So this is by dividing the external clock input signal by a programmable constants called prescaler. So then this is a sensor RAM where this word is written to 8257 for reading FIFO on sensor RAM. So in this mode, where AI and AAAA bits are of no use, this will automatically drive the database for each subsequent read. So in your sensor matrix mode, the bit AAA select one of 8 rows on RAM, and read display mode. So the CPU writes the command word to 8279 to prepare it for display RAM read operation. If AI equal to 1, the address will be automatically incremented after each read and write to the display RAM. And in your write display RAM, this command enables a programmer to write the display of the RAM. So AI is your auto incremented flag, okay, and display write and inhibit. So IW here represent inhibit write flags, and BL represent your blank display bit flags. So here your CD2 must be 1 for enabling a clear display command, and if your CD2 is equal to 0, the clear display command is invoked by setting, and where CA is your clear all is equal to 1 for maintaining CD1 and CD0, and CF is your clear FIFO, and CA equal to 1 that combines the effect of CD and CFs. So next is your sensor mode. This commands a lower IRQ line and enables a further writing into the RAM. Otherwise, the change in sensor value is detected, the IRQ goes high in heads of sensor. So thank you. If you have any clarification related to this topic, please communicate me. Thank you.